Welcome to Literary Insights. This is the summary of the book Einstein, His Life and Universe. If you like this content, please consider subscribing and liking this video. The author thanks many experts, scholars, scientists, editors, and readers for reviewing and providing feedback on the book. Diana Buchwald, the editor of Einstein's papers, gave guidance and access. Physicists like Brian Greene and Lawrence Krauss edited scientific sections. Historians like Arthur Miller and Sylvester James Gates edited. High school teachers and non-scientists reviewed the book too. The author takes responsibility for any errors. Michel Besso was Einstein's closest friend, an unfocused engineer who followed him to the patent office. Niels Bohr and Max Born debated quantum theory with Einstein. Helen Dukas was Einstein's loyal secretary for 25+ years. She protected his legacy after death. Arthur Eddington and Paul Ehrenfest supported Einstein's work. Edward Einstein was troubled son. Elsa Einstein was their second wife and cousin. Hans Albert and Ilse Einstein were children. Lieserl may have been an illegitimate daughter given up for adoption. Hermann Einstein was father, engineer. Pauline Koch Einstein was mother. Maya Einstein was sister who lived with him. Abraham Flexner founded the Institute for Advanced Study and recruited Einstein. Philip Frank wrote about Einstein. Marcel Grossmann guided Einstein to math for general relativity. Fritz Haber recruited Einstein but promoted Jewish assimilation. Konrad Habicht was in the Olympia Academy. Werner Heisenberg formulated the uncertainty principle Einstein doubted. David Hilbert raced Einstein to find general relativity equations. Philip Leonard inspired Einstein but became an anti-Semite. Hendrik Lorentz was a father figure. Mileva Maric was first wife, physics student. Robert Millikan confirmed the photoelectric effect. Hermann Minkowski called Einstein lazy dog, but devised special relativity math. George Nicolai was a physician, pacifist and probable lover of Ilse Einstein. Abraham Pius worked with Einstein and wrote his biography. Max Planck was an early patron until Nazis took power. Erwin Schrödinger pioneered quantum mechanics but joined Einstein in doubting uncertainties. Maurice Solovine founded the Olympia Academy and became Einstein's French publisher. Leo Szilard patented a refrigerator with Einstein and conceived of nuclear chain reactions. Chaim Weizmann brought Einstein to America and was an Israeli leader. The Winteller family took in Einstein. He met his first wife there. Einstein revolutionized physics with theories of special and general relativity. Born in 1879, Einstein loved physics from an early age. In his Miracle Year of 1905, he brought pioneering papers on the photoelectric effect, Brownian motion, special relativity, and E=mc². His theories changed ideas of space, time, and gravity. Einstein won the Nobel Prize in Physics in 1921. His theories proved accurate many times and led to new technologies. However, he tried and failed to unify relativity and quantum mechanics for decades. Einstein was a loner who fought conformity. He made extraordinary contributions to physics and shaped a new scientific worldview to symbolize genius and humanity's quest to understand nature. Einstein spoke slowly as a child, believing this let him think creatively and question authority. His middle-class Jewish family valued education. His father was an engineer who struggled to find work. His mother instilled curiosity. Einstein was close to his sister and grandmother, who gave him a geometry book. Overall, his upbringing nurtured his intellect and independence. Einstein rebelliously questioned authority and rigid teaching methods, preferring to study what interested him. He rejected German citizenship and Judaism as a teen but later became Jewish. Einstein struggled experimentally but excelled theoretically and mathematically, preferring thinking for its own sake. Professors noted his brilliance and indifference to unstimulating topics. Einstein was influenced more by theories he read himself, Maxwell, Boltzmann, than lectures. He studied informally with friends more than attending classes. His attitude and indifference antagonized some professors, but his friend Marcel Grossmann recognized his genius. Grossmann's help was vital to Einstein's success. Einstein's rebellious spirit, passion for theoretical physics, and desire to follow his intuitions defined his unconventional path to becoming a scientist. Experiences at Zurich Polytechnic helped shape his thinking and showed his determination to forge his way. Einstein and Mileva Maric took a romantic Italy trip in 1901, where Maric became pregnant. Though Einstein promised to marry her and find work, he seemed unconcerned with parenting. Marek kept the baby, hoping their families would accept them. But Einstein left Marek alone that summer to vacation with his family. Marek retook and again failed finals, forcing her to give up science. She told her parents in Serbia of her failure and pregnancy. Einstein's job search struggled. Though his friend Besso tried helping him find work in Italy, and Grossman told him of a patent examiner opening, Einstein remained unemployed. He believed Professor Weber gave unfavorable references, hampering his efforts. Einstein invited former lover Marie Winteller to join him, but she declined after a letter from her family. Einstein and Marek's relationship was tumultuous. She became pregnant again after this rejection. This describes Einstein's continuing job struggles, Marek's second failure/pregnancy, and the ups/downs with Marek/Winteller. Despite difficulties, Einstein remained optimistic. Marek asked Einstein to write her father explaining their situation. Marek was pregnant with Einstein's child, but they weren't married yet. Einstein had to keep the pregnancy secret from family/friends. Marek asked Einstein to write her father, likely for permission to marry. But no evidence Einstein wrote/sent a letter. Their daughter Lieserl was born in January 1902. Einstein didn't visit Marek/the baby, leaving Lieserl in others' care. Einstein told almost no one of her existence. Einstein and Marek married in January 1903. By then, Lieserl had either died of scarlet fever or been given up for adoption. Few details of her fate are known. Einstein found intellectual fellowship with friends Maurice Solovine and Konrad Habicht, forming the Olympia Academy. They discussed philosophy/science, read classics, and gave Einstein's mind room to explore ideas. Empiricist philosophers like Hume, Mach, and Spinoza greatly influenced Einstein. They emphasized gaining knowledge through experience/observation over pure logic. Their ideas on space, time, and determinism later influenced Einstein's theory of relativity. Classical physics and strict causality dominated in 1900. But relativity and quantum theory were brewing and would shatter these. Einstein admired classical physics determinism but saw its limitations. This covers critical details, events, and themes regarding Marek's pregnancy, their daughter Lieserl, Einstein's influences, and physics around 1900. Please ask for clarification/expansion. Classical physics portrayed a deterministic universe with absolute cause/effect laws. But relativity/quantum theory revealed a universe governed more by probabilities/chance. Einstein was troubled by quantum theory's implications, declaring, "God does not play dice with the universe." He spent decades searching for a unified theory restoring determinism but failed. Relativity and quantum theory seemed irreconcilable. Quantum theory arose from realizing energy comes in chunks. But it suggested reality is probabilistic, not deterministic. Einstein doubted this and looked for a unified theory but never found one. Einstein struggled for years to develop the correct field equations for general relativity. He pursued two main strategies, relying on physical intuition and mathematical deduction. Initially, he had vital insights linking gravity and the curvature of spacetime but needed help to develop the complete theory. Einstein's 1912 notebook showed his early attempts to relate matter distribution to spacetime curvature. His crucial breakthrough was recognizing that gravity arises from the curvature of spacetime. However, finding the correct field equations proved challenging. His first theory, the Entwerf theory, met some physical requirements but needed more mathematical elegance. Einstein aimed for physically reasonable and mathematically beautiful equations according to the principles of general covariance and simplicity. His intuition strategy yielded equations satisfying some physical criteria but needed more elegance. His deduction strategy produced elegant covariant equations that seemed to fail physically, so he discarded them. After years of struggle, in 1915, Einstein finally succeeded in developing field equations that were physically and mathematically satisfying, the Einstein field equations of general relativity. These equated the curvature of spacetime to the density of mass energy and momentum within it. They were covariant, simple, and matched predictions to physical observations. General relativity fundamentally shaped modern physics by showing how mass energy determines the geometry of spacetime, which then guides the motion of matter. Einstein's breakthrough required tremendous creativity, intuition, and determination in the face of years of frustration and obstacles. But his final theory was a monumental achievement that changed our understanding of space, time, and gravity. Einstein's two main strategies in developing general relativity were his aims for the theory, his initial failed attempts and theories, his final success in 1915 with the Einstein field equations, the implications and importance of general relativity, and the immense mental struggle required for this breakthrough. Albert Einstein proposed his theory of general relativity in 1915. It described gravity as the curving of space and time by matter and energy. General relativity implied an expanding universe, contradicting the static model of the time. To reconcile this, Einstein added a cosmological constant. General relativity predicted that massive objects like the sun would bend light. Einstein calculated that morning near the sun would turn by 1.7 arcseconds. Eddington's 1919 eclipse expedition confirmed Einstein's prediction, validating general relativity and making Einstein a celebrity. Fame brought Einstein difficulties and opportunities. He valued solitude but maintained relationships. His detachment strained close relationships but enabled creativity. He reconciled with Mileva and supported his family despite facing attacks and Germany's troubles. Einstein advocated for moral causes like Zionism while grappling privately with complex views on Judaism and nationalism. Publicly opposing anti-Semitism, he faced attacks targeting his identity and work. Fame grew from an iconic trip to America and associations with leaders, though his theories remained incomprehensible to most. Einstein's early work on light quanta and quantum statistics was groundbreaking but troubled him. His belief in determinism clashed with quantum uncertainty. He sparred with Niels Bohr over quantum theory, seeking to show its incompleteness. Experiments supported quantum theory, frustrating Einstein. Einstein won the Nobel Prize for the photoelectric effect, not relativity. His fame and moral stands made him an ideal laureate, but relativity's verification came later. The prize reaffirmed his controversial light quantum hypothesis and renown. Relativity's experimental validation led to more significant acclaim. In later years, Einstein sought to unify electromagnetism and gravitation in a field theory. He worked apart from mainstream physics on a grand but futile, unified field theory. His detachment from colleagues and solitary struggle made for a poignant final quest before he died in 1955. Mileva cared for Einstein in old age after suffering a stroke. She died shortly before he did, leaving him alone at the end. They had a long, complex relationship, maintaining connection despite difficulties. Their sons outlived them both, continuing the legacy of a man who reshaped his understanding of space, time, and the cosmos. So, in summary, Einstein's most significant scientific achievements were the theories of relativity and contributions to quantum theory, though the latter deeply troubled him. His work made him a renowned but controversial figure who grappled with fame and advocated moral causes. Solitude enabled creativity but strained relationships, which remained enduring despite hardships. A final solitary quest for unification poignantly concluded a life that reshaped our understanding of space and time. Einstein lived a humble life focused on his work. He was often forgetful in daily life but helped neighborhood children with homework. After Elsa's death, he was devastated but found comfort in his position. Einstein's relationship with their son Hans Albert improved. After Hans Albert's wife died, he visited Einstein in Princeton. Hans Albert later worked in South Carolina, where Einstein would stay. Though Einstein embraced his Jewish identity, Hans Albert converted to Christian Science. Einstein proposed a thought experiment showing quantum mechanics was incomplete because it only ascribed definite reality to properties once measured. Bohr said the particles were entangled, so measuring one affected the other. Bohr argued uncertainty still held, and quantum mechanics was consistent if you considered the whole experimental arrangement. Einstein tried to find contradictions in quantum theory to prove it was incomplete. His objections made Bohr clarify and improve quantum mechanics but did not disprove it. Bohr respected Einstein but believed his view was mistaken. Their debate shaped quantum theory's interpretation. As Hitler rose, Einstein warned about the dangers of nationalism and dictatorships. He urged pacifism, but his view changed after World War II began. He advocated the US develop atomic weapons to deter Hitler, though he was horrified they were used on Japan, and pushed for arms control. Einstein and refugee physicists were worried after Germany annexed Austria. Einstein left on a long trip when news reached him that German Jews were facing more persecution. He decided not to return home again. His property was seized, and he officially resigned from Prussian Academy. Einstein spent his final years urging world government and cooperation. He continued work on a unified field theory but with limited progress. His declining health meant less time for work. When he died in 1955, flags were flown at half-mast in tribute to his irrevocable impact on science and humanity. The key events are: Einstein's debates with Bohr shaped the interpretation of quantum mechanics, though Einstein's objections did not disprove it. Einstein's relationship with Hans Albert improved over time, though Hans Albert converted to Christian Science. Einstein lived but helped neighborhood children with their schoolwork. He was devastated after Elsa's death. Einstein warned about nationalism and dictatorship, urging pacifism and then advocating for the US to develop atomic weapons to deter Hitler. He pushed for arms control after World War II. Einstein and refugees were worried after Germany annexed Austria. Einstein left on a trip, deciding not to return home. His property was seized, and he resigned from the Prussian Academy. Einstein spent his final years urging world government and unified field theory. Declining health limited his work. Flags flew at half-mast when he died in 1955. Einstein shaped science and humanity irreversibly through his work and moral example. He advocated for liberty, equality, and human development against the tide of tyranny in his era. Einstein believed in an objective reality independent of observation. This contradicted the Copenhagen interpretation of quantum mechanics that held fact depends on measurement. Einstein's arguments against quantum mechanics failed but influenced physics and philosophy. Though Einstein's attempts at a unified theory were unsuccessful, his optimism and determination inspired others. His intuition and reasoning led to breakthroughs in relativity, though he later struggled to accept discoveries like nuclear physics. Einstein reluctantly helped warn of the threat of Nazi Germany developing atomic weapons after his friend Szilard urged him to sign letters to Belgian leaders. This unintentionally led to the Manhattan Project. Einstein later regretted his perceived role in the atomic bomb. Einstein advocated for world government and nuclear arms control to prevent war. He saw nationalism as outdated. His proposals for controlling atomic secrets and components to establish global security were idealistic but faced political realities. Einstein avoided most publicity but allowed some use of his name and image to promote causes he supported, like controlling atomic energy. He refused to assist with some misleading portrayals of the Manhattan Project. Einstein was known for his kindness, humor, and enjoyment of simple pleasures. Though controversial, his views aligned with his defense of intellectual freedom and opposition to oppression. He made peace with old friends and family in his final years. Einstein's genius came from his passion for understanding nature through imagination and intuition. His visual thinking allowed creative leaps in developing theories of relativity that revolutionized physics. He sought to unify concepts and find an overarching view of fields. Einstein questioned assumptions and thought freely without constraint by authority. He aimed to unify knowledge into a coherent whole. He felt humility before the universe's mysteries, even when confident in his unorthodox ideas. Einstein struggled in some early studies but excelled in math and physics. He had trouble finding a job after college but worked in a patent office, allowing spare time to develop groundbreaking ideas. His unconventional thinking challenged views of scientific creativity as inaccessible. General relativity proposed in 1915 described gravity as the warping of space and time by matter and energy. It revolutionized concepts of space, time, and gravity. Einstein developed general relativity through intuition, imagination, and an inductive approach, proposing and revising theories based on insights and thought experiments. He sought relativistic invariance, like the speed of light. General relativity predicted light bending and the precession of Mercury's perihelion. Experiments confirming these effects cemented it as the premier theory of gravity, displacing Newton's theory. General relativity modified Newton's theory of gravity and restored determinism. It explained inertial motion via the geometry of warped spacetime. It proposed a revolutionary view of spacetime and geometry. The mathematics of general relativity used tensor calculus and Riemannian geometry. Einstein and mathematicians like Hilbert developed the field equations relating the geometry of spacetime to its matter and energy content. General relativity has many applications, like predicting black holes, gravitational waves, etc. It provides mathematical models for cosmology, the structure of the universe, and the geometry of space itself. Einstein spent decades attempting to extend general relativity to unify it with electromagnetism. But his unified field theory was ultimately unsuccessful. General relativity alone is one of the most outstanding scientific, intellectual achievements. Einstein used brilliant intuition and imagination to formulate relativity. His theories proposed strange concepts that were nonetheless rooted in geometry and physics. They have stood the test of time and experiments. General relativity transformed physics and our understanding of space and time. It represents Einstein's crowning scientific achievement and one of the most significant demonstrations of the power of human creativity and imagination. The essence of general relativity, including its key concepts, development, predictions, and applications, its relationship to previous theories, Einstein's approach to formulating it, and its significance and enduring influence on physics and our understanding of space and time. General relativity posits that gravity arises from massive objects curving or warping of space and time. Huge things cause distortions in the fabric of spacetime, influencing other objects' motion. This is summarized in the equivalence principle, relativity principle, and the view that space and time are relative depending on the observer. Einstein proposed general relativity to extend special relativity and resolve its incompatibility with Newtonian gravity. His approach focused on tensors and required the theory to take the same form in all coordinate systems, covariance. The theory was gradually accepted after Einstein proposed it in 1915, and it was supported by observations of starlight bending during solar eclipses and the perihelion precession of Mercury's orbit. However, some scientists remained opposed. General relativity revolutionized concepts of space, time, and gravity. It has many applications, like modeling black holes and the universe's expansion. However, it is incompatible with quantum mechanics, motivating the search for a theory of quantum gravity. The theory represents a radically new vision of geometry, space, time, and gravity. It posits that geometry is not absolute but depends on the matter and energy in spacetime. This paradigm shift initially faced resistance but has gained broad acceptance and influence. Additional details explain general relativity's postulates, consequences, and applications. Analogies and explanations promote public understanding, though this summary is not comprehensive. The summary highlights how general relativity represents a revolutionary reconceptualization of space, time, and gravity, how it gradually gained acceptance though initially controversial, its core principles like the equivalence principle, applications and open questions in physics, and additional context to facilitate understanding.